Hey everybody, welcome to week 3 of Research Methods in Psychology in Dr. Kirby's living room. Let's get started. So in week 1, you studied how to critically read psychology headlines, and in week 2, you've started developing research ideas of your own. So now let's take a look at what we're doing in week 3. This week for our textbook chapter content, we're talking about the concepts of reliability and validity. They'll help you learn how to measure more consistently and accurately. Then we're going to start refining your research questions by reading the research in your topic areas. So remember how we talked about in last week the steps to developing a hypothesis? You're going to start with a broad research idea, then frame it in terms of a question. Then you need to make that question a little more specific with clear variables and a prediction. To know what scientists normally call those variables, those concepts, and which relationships are going to make most sense for you to predict, you need to read more research that's already been done on that topic and search for articles using the processes and the library databases and Google Scholar like we looked at in previous weeks, not plain Google searches. After you've found those sources, you're probably going to need some help reading them. It takes different skills than reading novels and different skills than reading a textbook. So I'm going to walk you through that this week too. Reliability and validity are foundational skills that you need for future lessons in this class. They help us evaluate research that's already been conducted and better design our own research to be more accurate and consistent. Reliability just means how consistent your measurement tools are. Do they come up with close to the same results every time you would measure the same thing using the same tool? If so, the tool has high reliability. A measuring tape has high reliability, because if you measure the same object using that measuring tape, it's going to give you the same results every time. Whereas counting your steps to measure distance would have lower reliability because you might do that inconsistently and it depends on whose steps they are. So counting things in paces is not a very reliable measure or consistent over time measure of distance. Validity, on the other hand, really means accuracy. It's a different concept from the reliability or the consistency that I just introduced. Validity is a way of evaluating how accurately our test measures the concept that we think it measures. So with that measuring tape, are the inches marked on it accurate to actual inches? So when you measure with that measuring tape, would it give you the true value of the length of that object or distance? Then if we were to ask that with the steps, like we looked at earlier, we would be asking, is your foot actually a foot long, right? Or is each step that you count actually the distance that you think it is? So we're looking at two bullseyes here. There's one on the left with the label both reliable and valid. It has 4 concentric rings in this kind of purple color. We've got a red dot in the center to indicate the bullseye, the actual target, and then we have dots to indicate where the darts were thrown or where the arrows landed after they were shot. So those little blue dots show that the hits are clustered very, very close to the center dot. One of them is actually on it. And they're also clustered very, very close together. So the reliable part is the fact that the blue dots are close to each other. We're coming up with a similar result every time. The fact that they are close to the red target in the center is the valid part. They're close to the accuracy we're looking for. On the other hand, the one on the right shows neither reliable nor valid. We have blue dots that are scattered all across the top half of the bullseye, but only one is even within that smallest ring close to the target. So they're not reliable because all of the darts are scattered far away from each other. Your second dart didn't land anywhere close to your first one. They are also not valid because none of them, especially overall, are really close to the target in the center. We have another set of bullseyes. On the left, we have one that represents reliable, not valid. And that shows a lot of our blue dots clustered very, very close together. So remember, if they're consistent with each other, that's reliability. If your second dart ends up close to your first one, it's reliable, even if your first one's not close to the target. And that's what we're looking at here. We have all the darts clustered in the top right quadrant, very far away from the target in that last concentric ring, but they're close to each other, which makes them reliable. And then this one is less common, our final one, and it's a little more difficult to visualize and understand, for me at least. Valid and not reliable is when we have observations, in this case, where our darts landed, that end up being, on average, if we took the mean of the distance of each of these dots from the center, the mean comes up close to the center. So they're clustered around it on average. There's not a whole lot of them that are actually that close themselves individually, but they're not reliable because they are spaced far apart from each other. So let's break this down with one more example. Imagine that we had a speedometer and we were curious how reliable and valid it was. And maybe we could compare its results. Let's say you had two speedometers in your car, one that you know has been manufactured accurately and reliably, so you have one to compare it to. And we've got this new one, and we want to test out how reliable or valid it is. Imagine that your true speed we're trying to measure is 58 miles per hour, as we see in the image. Imagine that the first time we did this with, let's say, speedometer A that we're testing, we measure that you're going 60 miles an hour 4 times in a row. We measure that. Your foot hasn't changed on the accelerator, and we get this consistent measurement every time. But your true speed from the accurate speedometer we know about is 58. So I'm going to ask you to take the quiz below to determine whether this speedometer that we're testing is reliable, valid, reliable, not valid, etc. Any combination of those. On the other hand, imagine that you had these 4 different measurements: 54 miles an hour, 62, 63, 52. Now again, your foot hasn't moved on the accelerator, so we can be fairly certain that your true speed hasn't changed and that it's still 58. So with this speedometer B that we're testing, again, try this out in the survey below to figure out whether you think it's valid, reliable, any combination of those two, to try this concept out for yourself. And now, pause the video and do that and come back really quick for the answers. So if your true speed is 58 and speedometer A measured 60 4 times when your speed had not changed, it's consistent. That's good, but it's a wrong measurement every time. So we know that it has that consistency, which is reliability. It has high reliability, but it has lower validity. It's not as accurate. If, however, with speedometer B that we're testing out, we tested 4 times and we got 54, 62, 63, 52, those actually are not reliable like the one before. They're not consistent numbers every time. Your true speed is 58 and has not changed, but we get these measurements that are all over the place. However, if we took the average of these, we find out that the average is 58. So on average, they are close to your true score. So we can say it has pretty good validity, but its reliability is not great.